All right, so let's finish up these notes. So the last part, we finished up part B completely. Let's just finish up part C. So we're going to write the first three non-zero terms and the general term. So we need both parts of the Maclaurin series for g prime of x. So this is g of x, right? So g of x is this. So all we have to do really is derive the series that is given to us. So the derivative of x over 3 is going to be 1/3, right? Derivative of x cubed over 5, remember, bring down the 3. So that's going to be 3/5 x squared, right? Derivative of this is going to be 5/7 x to the 4th. So g prime of x is equal to 1/3. That's a minus, right? From up top, minus 3/5 x squared plus 5/7 x to the 4th minus dot, right? It just wants the first three non-zero terms. So this is term 1, term 2, term 3. And we need the general term. Well, we already have the general term right here. And you already know that when you derive, this 2n minus 1 is going to come down. Okay. That 2n minus 1 is going to come down, and then we're going to subtract 1 from this. It is still an alternating series, so we do have to keep that negative 1 to the end where it is. Okay, so even though we are deriving, we're not deriving everything, we're deriving just the part that includes the x. So you notice anything with the n is part of the series, so we're not going to be deriving that. Okay, so plus negative 1, we got to keep that there because it is still an alternating series, even the derivative of it. That 2n minus plus 1 comes down, times x to the 2n plus 1 minus 1, which becomes 2n. And all of that is over 2n plus 3. Because remember, we're just taking the derivative of x, not the derivative of n. Okay? We're figuring out dx dy, I guess you can say. N is just the term number. And that's it. All done with that. All right, the next part says a function f has a derivative of all orders at x equals 0. So let's let Pn of x denote the nth degree Taylor polynomial about x equals 0. So this, what type of Taylor polynomial is this? This is a Maclaurin. It is known that f of 0 is -4 and that P1, which basically means the first degree Taylor polynomial once you plug in half, is equal to -3. Show that f prime of 0 is going to be 2. Well, because we have P1 is equal to -3, we know that if we write out the Taylor polynomial for P1 of x, that's going to be f of 0 plus f prime of 0 times x minus 0. I don't need that because it's a Maclaurin series. I'm just going to write it right now so that we know that what we're talking about when it comes to the center. Okay. And that's it. That's the first degree Taylor polynomial right here. So the parts that we do know about this, we know what P1 of x is. That is equal to -3. We know what f of 0 is. That is equal to -4. Plus, we want to show that f prime of 0 is 2. So that means we want to solve for f prime of 0. We don't really know that it's 2 yet. And that's going to be times x. All right. Now we also know what this x is, what we are approximating. When the polynomial negative 3 is equal, sorry, when the Taylor polynomial is equal to negative 3, we know that x, in order to get that negative 3, we plugged in 1/2 in for x minus 0. So now we're just going to solve for f prime of 0. So first we're going to add 4, right? And then multiply by 2. So we add 4, that's going to be positive 1 multiplied by 2. Well, that gives us 2 is equal to f prime of 0. So we just showed that f prime of 0 is equal to 2 given the information that we have. All right, next up, it is known that the second derivative is equal to negative 2/3, and the third derivative is equal to 1/3 at 0. Find P3 of x. So here we just need to find basically the third degree Taylor polynomial. Okay, centered at 0. So that's technically a Maclaurin, but we don't need to call it that. And that's going to be an easy one. So P3 of x is equal to, well, we know f of 0 is negative 4, but I'm going to write this in right now. So we got f of 0 plus f prime of 0 times x, right? It's centered at 0, so that's why I'm not putting a center there. Plus f double prime of 0 times x squared over 2 factorial plus, we want to go all the way to the third degree, so f triple prime of 0 times x cubed over 3 factorial. Now when we plug in the information that we know that f of 0 is negative 4 plus f prime of 0, we just proved that it is 2 times x, plus f double prime, well, we know that that's going to be negative 2/3 times x squared over 2 factorial. We'll come back and clean this up in just a second. Plus f triple prime is 1/3 x cubed over 3 factorial. Okay. So now when we do the math, when we clean this up, we've got negative 4 plus 2x. Well, the 2's here, they will cancel out. So we've got minus 1/3 x squared plus 3 times 2 is 6 times 3 is 18. So we got 1/18 x cubed. And that is equal to P3 of x. All right, example 6, part C. The function h has a first derivative given by h prime of x is equal to f of 2 of x. It is known that h of 0 is 7. Find the third degree Taylor polynomial for h. So what we've been working with right now is basically P3. We just solved for P3 of x, right? We are letting f of x be approximated with P3 of x. So from our last example, this is what we got. The only thing that this is basically saying is that h prime of x is the same thing as f of 2x. So if we combine these functions by composition, right, if it's a composition function, you're basically taking x out and replacing it with 2x. So for the problem, for the Taylor polynomial, we're just going to replace x with 2x. So wherever there's an x, I'm going to put in a 2x. And this right here is equal to h prime of x, right? H prime of x is equal to f of 2x. And that is approximated with the Taylor polynomial at 2x. Now when we clean this up, we've got what do we have? We've got h prime of x, right? Which is equal to -4, or approximated using that Taylor polynomial. -4 plus 4x minus, this is going to be 4x squared, so minus 4/3 x squared. This is going to be 2x cubed, so 8 divided by 18. We've got 4/9 x cubed. Now that is h prime of x. Now what they want is they want the third degree Taylor polynomial for h. So what do we got to do to that h right here? Okay, so because we want the Taylor polynomial for h, and we want the third degree Taylor polynomial, this is the third degree Taylor polynomial for h prime of x. So in order to figure out h, we need to integrate. Okay? And when you integrate h prime of x, you've got h of x. And that is going to be approximated with p3 of x. The integral of -4 is -4x. The integral of 4x squared, 4x, sorry, is 2x squared. The integral of -4/3 x squared is, bring the, add 1, right? Add 1 to 2, and then divide by 3. So we've got -4/9 x cubed. And of course, this is an indefinite integral, so we are going to be adding c. So how do we solve for the c? Well, we know that it's centered at 0, but we also know that h of 0 is equal to 7. Okay? So once you plug in 0 in for the x's, we know what that h of x is going to be, and that's going to be 7. So in this case, c is equal to 7. And now that I have my c, I know that h of x is approximated with p3 of x at 7 minus 4x plus 2x squared minus 4/9 x cubed. Remember, the coefficient has to be first. And that's it. That is how we use all the parts of Taylor polynomials in order to solve these. All right, enjoy.